Okay, so hello everybody and welcome to our webinar Systems Engineering Rigor Needs an Interoperability Framework. We are very happy to do this webinar together with the CIMdata. We have Craig Brown, Executive Consultant at CIMdata with us, and Juan Llorens, CTO at the Reuse Company. Let's take a look at the agenda. Craig will start with an introduction and an overview of CIMdata. Then he will define PLM and systems engineering. Next, he will talk about system engineering challenges and why decisions need broad digital interoperability. After that, Juan will introduce the SES Engineering Studio and do a demonstration. If you have questions, you can write them down in the question section anytime during the presentation. And in the last 15 minutes, Craig and Juan will answer them. Then we will finish with some closing remarks. So let's start. Welcome, Craig.
Well, thank you, Cecilia. And thank you, everyone, for joining us today. This is a topic that's been on my mind the last few decades. And I think it's important to understand not just system engineering, but system engineering rigor. And that's what I want to talk about today is how do you know you're getting the best possible answers from your system engineering organization? And part of it is an interoperability framework. And we're going to talk about that today and explain first what it is, and then show you an example where one's really working. For those of you that don't know me, I am retired from General Motors after about 30 years. Before that, I was in the aerospace industry. And my last assignment at General Motors was as their PLM leader. There's a lot of talk about product lifecycle management. And one of the key things I want to get across to you is how broad it needs to be. And then, of course, if it's broad, it influences systems engineering. I did retire in 2019, and a little bit later, I joined CIMdata. And I've been doing different kinds of consulting, both with companies like the Reuse Company, as well as industrial giants like my former employer. One of the other assignments I had along the way was managing the simulation methods group, so developing new ways of doing simulation that would help accelerate product development. And I bring that up in this context just to make it clear to you the view I come at systems engineering involves all kinds of product decisions, not just maybe classical system engineering, you might learn it in COSI, but how do you apply that across the whole product development cycle? I speak at lots of conferences. I do webinars like this one. And at the beginning of my career, I got a bachelor's degree in aerospace engineering. And as many of us in the car business came along, we got our black belts in design for Six Sigma. So Cecilia shared with you the agenda, so let's get started. I've known about the Reuse Company for a few years, and I got to know them really well about a year ago. And they sponsored some research that we did. And part of that was about interoperability frameworks. And we published a commentary in December of last year. And I wanted to share with you the key points from that commentary. First, product complexity is increasingly a systems problem, requiring effective, efficient systems engineering management solutions from product inception, so the original idea, all the way through operations, so the use of a product. You know, a lot of companies focused on product development, the handoff to manufacturing, and then mass produce it, and they moved on to the next product. Where systems engineering is evolving is the whole life cycle, and we're going to talk a bit more about that. You know, requirements for a product must be well written with no ambiguity. We all say this, but it's really hard to do it well. And so these same requirements, once well written, should be shared or made available so people can view them. But it's way too easy with all of the personal computers to duplicate them. In other words, make a copy for my own use. And the trouble with that is it leads to confusion, wasted time, and in extreme cases, poor product performance. We're just using the wrong versions of requirements. Another thing that you want to consider is we got all these models now. Now, when we talk to mechanical engineers, they're thinking of a 3D model that you assemble, which is fine. If you talk to an embedded software engineer, they're probably talking about a functional model. How does this feature in a car move me along the road? There's also electrical and structural and sometimes just first principles based on some key equations. All of these are models, and all of them need to be authored well and not allow ambiguity. They also need to be shared, just like requirements need to be shared. And of course, they get refined, especially during product development and manufacturing engineering. They evolve quite quickly. So any copy of any of these engineering items will lead to confusion and wasted time, just like copies of requirements. So how do you maintain this systems engineering thread is one of the key elements of a digital transformation strategy. It's one of the key elements of doing really good systems engineering. So you need the necessary technical processes to be digitized. In other words, have computers help you execute the process. And you got to realize there'll be lots of tools, and some of them will be of your own invention, like that methods group that I used to manage. You'll also use commercial PLM systems. And the trouble with using more than one of them is then you got multiple file management systems that can likely cause copies of things and then maybe some uncontrolled copies. Now, researchers, and Dr. Lorenz is one of those we're going to chat with here in a bit, have developed ontologies, so if you will, a way to have a precise language that you can communicate clearly between 2 points in space or 2 points in time, or if you will, 2 points in your model universe. With an ontology, you can then refine requirements, even model elements, and all the other things that come along with product development with confidence that you haven't confused anybody or that you haven't become ambiguous along the way. Now, computer databases, especially computers today as they become so fast, can help enforce this semantic clarity. And that's one of the things, we talk about grammars in languages, and sometimes engineers that aren't linguists or computer scientists don't want to have a talk about a grammar, but it's really important to have data governance, a clear way to describe each of your elements in your design. And authors can then use the solutions to author the best requirements, models, and things. When I say author, I'm talking about the creator of a data element, whether it's a requirement, a model, even the analysis you do when looking at test results. And the goal is clear, concise, precise, and concise, and measurable information that you have confidence in. The Reuse Company, which I'm helping introduce today, if you don't know who they are, they provide such a solution for knowledge gathering, classifying and sharing, and even quality enforcement. And I'll let Dr. Lorenz explain a little bit further how they did that. But what's important to me as a former industrial PLM leader is how important it is that we communicate clearly between these different elements. So my point is systems engineering needs rigor. In order to get rigor, you need an interoperability framework. And the whole point of the interoperability framework is to let there be communication between all the information sources. Even coordination, maybe more than moving of anything, just making sure things are consistent. If you don't know who CIMdata is, we are entering our 40th year in PLM education, research, and consulting. We help all kinds of clients, from software solution vendors to industrial giants, and even some universities in understanding where PLM needs to go. It's our mission to maximize your ability to design, acquire, deliver, and support innovative products and services, whether you're a tool vendor or you're building a commercial product. We have a couple pictures that kind of describe the breadth, and one of the things I want you to take away today is we're not a single solution thinker. We're thinking about the broader systems, just like systems engineering would do. We have three elements of our business centered around research. So we look at markets, we look at trends, we do some predictions about where things might go. We teach. Today's webinar is an example of that. I've just taught you the few points that came out of the commentary. And then we do consulting, which oftentimes leads to a position paper, or sometimes it leads to just advice back and forth, like we've been doing with the reuse company in the past year. You'll see these little icons as I speak today, the eyeball for research, the brain connecting things for leadership, and the light bulb when we're talking about inventing new things. We have lots of clients, and if you want to know more, come to our website and take a look. This is just a teaser. And with that, let's get a clear definition of PLM. You know, it's a data backbone and a process backbone that's supported by modeling and simulation, which leads to this connection of data and processes across the enterprise. For CIMdata, and we encourage all of you that are interested in the PLM space, this broad definition of PLM is what we all need to follow. It covers portfolio management for products, ideation or creation of a product, managing the profitability of the company, so quality and compliance, and then also dealing with the service lifecycle. It's an approach that spans the whole lifecycle, even to disposal at the end, where we might be reusing the material for the next generation product. Here's a picture that I have borrowed from Dr. Eigner in Germany. And what I like about the picture is it shows 6 phases, kind of in a serial fashion. And it shows the different structures needed at each picture. Now, PLM is in the middle. It's the classic BOM structure for a list of mechanical parts, fasteners, bolts, pumps, fenders, chassis that go together. And then when you come around to evaluating them, first with physical test and then with simulation, you kind of use a very similar structure, right? But one of the challenges with PLM is it's kind of biased toward those mechanical structures, if you will, the manufacturing structure. Because that's where companies like the one I retired from make their money, is how do you streamline that handoff between product engineering and manufacturing engineering. Well, for features and even requirements that come from a customer, they may or may not be directly aligned to that BOM. And that's what these red arrows begin to show, is the relationships are at different points in the structure of information. You can go to the other extreme and talk about executing manufacturing, and that's where ERP and MES come in. And then if you worry about operations, well, that's the service lifecycle or a service BOM. System engineering, and I like what Dr. Eigner presented here, is that front part all the way till you start mass production. That's a place where system engineering needs to get really good, really rigorous. But you should realize that what might be really good for PLM might be different for requirements management. And in fact, a large group of us have embraced something called application lifecycle management, which is what ALM is. So think about, how do you keep this information flowing? How do you keep it connected without causing copies of files and other things like that? There recently, in the last couple of years, people have started to embrace the DevOps or this infinity model, and they talk about virtual products and the processes that support them being continuous. So as soon as you learn something from your users, it gets fed back into your product development, and it's managed by these MCAD, EDA, ALM, and there's an alphabet soup. And the truth of the matter is, systems engineers have to be aware of all that. Right? You're trying to manage the product-related intellectual assets. PLM can be and is this broad from our point of view at CIMdata. And if it's that broad, then systems engineering is that broad. Well, this brings back the question about, well, then how do we make it rigorous? One of the areas is a broader and broader use of simulation. At first, simulation replaced test as an efficiency thing. And then people realize, well, if you let the simulation drive the system development, you could look at options that before were just unaffordable to consider because they were too slow to produce, the prototype cycles and so on. We've seen the emergence of model-based enterprises based upon using models for systems engineering. So you hear about model-based systems engineering and how to apply models and simulation and analysis throughout the whole cycle. And it's this area of expansion where simulation's now driving the development process. This will cause lots of process changes, and it will make systems engineering the center of many, many, many decisions, not just planning decisions that used to be made only up front. This is one of our practice areas. We have, I think, 9 of them. And I just wanted to highlight to you that some of the developments along the road to digital transformation have a practice that needs to be further taught as well as embraced by the larger industries. Okay, so what are the challenges with systems engineering? Well, in our research, we work with different organizations, and one of them was the U.S. Department of Defense. And a couple of years ago, they published this position paper on the authoritative source of truth. And I really like the choice of words. You have to think about, well, what does it mean to be a source of truth? And you hear lots of people say a single source of truth. Well, that's what a PLM vendor likes to say, because then it would force everybody to use the same system. But in reality, the different parts of your company use different tools. That's largely for innovation reasons, right? And also for expertise reasons. So a more practical model of how a company works is this picture on the right that shows you the different areas. And then it shows you that they have to connect. They have to be able to talk to each other. So model-based enterprises, they have a notion of requirements discovery. And what I mean by that is it's really balancing wants and needs, desires and wants with needs. And really the distinction between what's really a requirement and what's just a desire. I heard a keynote at last year's INCOSE conference that I really liked, and he said, look, a requirement is an agreement across products and enterprises. So an enterprise agrees they know how to execute that requirement for a specific product. So think of it as an agreement rather than just a list of things that come from a client, and that's what requirements discovery is. It's its own engineering process. You'll hear me also say requirements engineering. People think, well, wait a minute, requirements are fixed. They don't change. Well, that's not true. They change all the time. They change due to markets. They change due to understanding. This leads to this notion of a authoritative source of the truth. And the Department of Defense, the people that were there at the time, they did a really good job describing what this means. One way to think about it is it's datum from many models, and it helps you make the decision, the next decision in your decision process for product development. So it's authoritative. It's the necessary information to make that decision. Whatever the source is, notice it's connected in the picture. I mentioned ontologies before. Think of an ontology as a Rosetta Stone. It's a way to clearly communicate between all these different nodes in this picture. It's going to enable better system understanding. It's going to be the foundation of your data governance. So what we need then is an interoperability solution or solutions that can streamline the connection between these nodes. It needs to be collaborative when needed. So when I'm getting ready to make the decision, that's what makes it authoritative, is the when. And then refinement in near real time. When you learn something, whether you learn it from the field or a similar experience on a similar product, you want to, as fast as possible, update the understanding in the model so that other people can benefit. So when we talk about interoperability across the enterprise, at CIMdata, we've identified 12 critical elements for digital transformation. And I just wanted to emphasize to you how much 3 of them, the digital thread, end-to-end connectivity, and this last point about data governance, they're really essential to building on an ontology, being able to connect end-to-end. And this is what a real digital thread or even a digital network is all about, is how you can connect it all. If you have an objective to do digital transformation, You absolutely should have a plan for each of these 12. And if you're worried about systems engineering rigor, these 3 are paramount. So let me spend another moment on the best practice in digital transformation. You know, as you want to change your company, you need to know what your strategic business objectives are. It's one thing to say, improve my system engineering. It's another thing to say, decrease my time to market so that I'm better than my competitor. Maybe system engineering can help with that, or rigorous system engineering. As you figure out your future strategic business objectives, then document your issues. Why can't you do it today? Look at the market, because things are changing, right? In the car business, there's a huge shift to electric propulsion. And then start identifying the drivers, the change drivers from the market, the solution drivers from what you're capable of doing, or what other people could bring to the party to help you improve. That'll lead to vision, which will lead to data governance and organizational changes, which could well be process changes. And eventually, you'll have an improvement in your business, but the important point is it'll tie back to your strategic business objectives. So I wanted to insert that in this presentation, just so you understand. It's one thing to say, I want rigorous systems engineering, but you should be able to identify how that improves your business. And it'll be different for different businesses, different market segments. So one last point before I hand the ball over. So building and keeping trust is crucial, right? This notion of authoritative source of truth is really important. And digital engineering can help. It can help across the collaboration across organizational silos. You know, that picture from the Department of Defense showed these kind of different silos from a modeling and a technology point of view. It's essential to have collaboration. New products, and especially new technologies in those products, think batteries and mass-produced cars, especially for electric propulsion, there's going to be new entrants into the industries. And so keeping trust as you get new entrants means managing knowledge well. You know, virtual contextual views of a product correlated with its actual use. In other words, as you discover something happening in the field, go update those understanding models so that you can make the next decision even better. That's how you build confidence, and that's how you keep trust, is that the knowledge you're getting from the customer usages is always available to help with the next decision. This is what emphasizes that requirements work is really an engineering job. It's managing the changes during development. The changes are driven by environment, or they're driven by your changing business objectives. And so back to Dr. Eigner's picture. So ALM, PLM solutions have to embrace interoperability, especially in systems engineering. You know, when interoperability was first introduced, they were talking about CAD exchanges from different CAD vendors, right? So just the mechanical shape and geometry and tolerances that you get in a CAD model. Well, interoperability is much broader than that. The word is clear, the word is defined well. It means that 2 points in the universe, be they in time or in space or both, can interconnect with each other, can work together. ALM and PLM need to do the same. So with that, I'd like to introduce the Systems Engineering Studio, and I had one of their pictures that I really resonated with because of its focus. And then I heard at the last Cozy conference held last summer, the folks from Safran Aircraft Engines are in fact using this. They're an early adopter. But there's 5 elements that I want you to be thinking about. One is this whole topic of requirements engineering, and how do you know you got a good requirement? Another is verification and validation. Well, of course, if you got a requirement, you should measure for it. Traceability, discovering what the linkages are between different elements of the design. The knowledge management and the patterns in knowledge that come about as you learn. And then finally, the approval or the authorization, if you will, the authoritation of the requirements and everything associated with them comes when you can generate test cases from requirements. Requirements are good if they're measurable. If they're not measurable, they're not such a great requirement. They're just a desire. So with that, I'd like to introduce Dr. Lawrence, and Juan, if you would, take it away. And I think I have to make you the presenter. I may have done that.
I make him the presenter.
Thank you, Cecilia.
Good. Super. Let me take the lead. So I presume that now can you see my presentation?
Yes, I can. Juan.
Very good. Okay, thank you very much, Craig, for this super good first part, putting everything in place for me to carry on. I would like to introduce myself first. For those of you that do not know me, I am a CTO in a reuse company. I will tell you now what reuse company is doing, but of course with this name it's not extremely difficult to understand. I also teach systems engineering at the university, one university here in Spain. I have been luckily quite active at INCOSI, both at chapter level here in Spain, also building working groups at central, or certifying myself or becoming a little bit more leader places there. And I got my PhD in robotics with a strange topic of software reuse. So a little bit on reuse company, of course. It's a little bit strange because perhaps those of you who know us are using the image of us just like being quality requirements, quality managers, and we have been that for many years, trying to locate all our technology within systems engineering domain. But reality is that we attempt, as Craig has lovely said, to fill all these problems that he has described. Basically, digitalizing system lifecycle management with all these three, sorry, I'm going to use my pen, my magic pen here, with all these three topics. So we want to digitalize it, guiding the process by reuse in all, and you will see in all different ways, driving it by knowledge and of course models, because it's what we consider it can be good, but not avoiding documents. We really think there's a bet that documents should not die. They must be there fully integrated with models. And by doing this, we want to have the technology to make this possible. And this is, as Craig has mentioned a little bit, trying to define integration hubs, connecting the ecosystem of tools that usually exist among different departments, projects, organizations, making these tools interoperable, because most of the times traceability at all sorts is completely necessary, and providing technical management support to all these tools. You mean quality is extremely important, that you have to have the quality of the system as well as being able to manage the quality of the requirements, of the models, physical models, the quality of the parts described, assemblies, the quality of the test cases, and so on. And quality verification, validation, configuration, management, decision management, risk management must be managed in the same way. So providing technical management to these connections, we think that it can also be interesting to enhance systems engineering at corporate side. So we want to do all this together with the digitalization of the system lifecycle, making workflows of them, using these tools, as well as not avoiding Microsoft productivity tools. I know these tools are banned somehow within us, but I don't think so. I think that these tools are lovely authoring tools, and they should also be integrated in them. So in order to do that, we would like to use the SES Engineering Studio. We offer it to the market. And this is the interoperability hub, sorry, that we want to show you in this presentation. I'm going to go quickly along these topics and try to make the demo as soon as possible. So again, SES attempt to connect tools, make them interoperable, provide technical management processes support for all of them. I don't know if I have to dig a little bit there, but I will show you then in the demonstration. So perhaps I just go quickly. Smart authoring, which is you want to write requirements, you want to draw models, you want to define parts, in which way these computers can help you to take better decisions when you do authoring. And orchestrating something that we call synchronized source of truth, which is our view of authoritative source of truth, which mainly means that where is the source of truth must be synchronized somewhere. And often MBRE as a concept, model-based requirements engineering, which mainly means do not have to leave requirements written in natural language. They must be there. We dream on natural language, or we dream on images, and it's a little bit difficult to dream with models. So we have to maintain them, but the models must be connected, and they must be updated and be integrated, or they must generate the requirements sometimes. Okay, and all of that using ontologies, which has been the core of reuse since the last 25 years. So,
Juan, excuse me. Can you change screen? You're showing the presentation mode.
Okay, but sorry about that. I thought I was sharing the screen. Okay, let me see. Which one is it now?
Yes, perfect. Thank you.
Okay, very good. So here is a little bit the image that I'm using to show all the processes. You have your tools. You can have whatever tools you're using, and in theory, what you need to do is to have an integration hub that connect them all to provide, including Office tools, to provide and technical management support, as well as all the interoperability aspect that we are talking here. You are not seeing what is written here because it's too small, but I'm just showing you in case of you are interested and we have time. We have here some demonstrators on how do we connect to Polarion, Doors, Cameo, Capella, Rhapsody, SolidWorks, and many others. Okay, indeed, the list is a little bit bigger, around 60 connections, and trying to cover the more and the more the whole systems engineering lifecycle environment with the tools that you use. So let's get now very quickly on interoperability, which is the topic today. So interoperability in our concept, at least what we're going to show you, is that you have tools in one side that have to somehow talk with tools in other side. So the idea, of course, is to extract whatever is necessary from the tool, being able to represent in a way that this interoperability is scalable among 60, tens or hundreds of tools, and then make the possibility to interoperate these tools by information transformation. Okay, so that's a little bit the essentials of this interoperability. We extract the information, we just bring it into the ontology. With the ontology, we are able to generalize this information. Through transformation process, we can generate the next one, which is posted back to the second tool. Okay, so this is a little bit the core of what we do. We think on interoperability in two levels. For those of you who can see, I have here some examples of what it can be done with this. So you can have interoperability at connection level, which means, let's say, interoperate the whole connection. You can, for example, generate models out of the requirements. You have the set of requirements. The set of requirements is the input, and the part of the new models would be the output. But you can also have interoperability at particular work product level, like bindings. Okay, you can have a simulation of a requirement, particular requirement with a particular number in a particular measurement unit that must be sent somewhere for simulating and getting back into the requirement the evidences that this requirement is executable, is possible, is achievable. And I can mention quickly some small demos there, but I think that if you are interested, perhaps we can show you other things if we have time. Generating linear temporal logic or creating Modelica models out of requirements or many other different things. Okay. So just directly out of that, I would like to start with a demonstrator. In this moment, I'm going to change the screen, and hopefully you will see a little bit. So I'm going to change the monitor to this big one monitor. I'm going to now start my, okay, I'm going to start this video that I have. I'm going to move this out. And in theory, can you see my video screen, right?
Yes.
Cecilia, confirm?
Yes.
Okay. Very good.
Yes, I
So,
can see it well.
Very good. So I'm going to traverse through 15-16 minutes of video. I will stop a little bit so that we can explain what I'm doing. I'm opening now the SES Engineering Studio, and the first thing we are going to do is we are going to decide in which ontology we want to work. The ontology is a topic in itself, so we should perhaps need an hour to describe what is going on in here, but at least the concept that we understand that exists in the market today is that you can have a specialized knowledge about the processes that you're doing. This can be represented in an ontology, but you cannot, at least it's what I know, you cannot have an ontology for the whole world. You cannot have an ontology for your Boeing company. You have to have small parts of ontologies that can be mounted in each other. So you can have a small ontology for fuel consumption problems. You can have an ontology for integration process. You can have an ontology for, so you can select your ontology. Okay, the first thing you have to do. And this ontology in our case is relational database systems. So once you connect to one ontology, which at least also is a repository, you get connections. So you can see that in these cases, you can this computer program is connected or can be connected to several different tools at the same time. Okay, you can see Word, Excel, Jira, Capella, Cameo, and CRML, Rhapsody, Polarion, Simulink, whatever. Okay, so so the intention is that you can have integrated whatever as many connections that you have, and these connections usually cover quite a lot of different tools. Of course, the number of tools is completely unlimited, so the more needs of tool, the more connections have to be built there. Okay, so when you connect to a connection, in this case we are connecting to Microsoft Word, what you get is a synchronization of the information between Microsoft Word and the repository. So as I will show you in a second, you get in every single connection against the Word document, you get what is it that exists in Word and what is it that exists in the repo. And this is going to happen for any connection of the 60 that we provide or 80 at the end of this year. So immediately you connect something and you connect to this element, you will see what is the difference between the last time you connected to the repository and the work in between that has been done after that. At parts, at Teamcenter, or at I don't know, Cameo, Rhapsody, or Doors, or whatever, or Word. So I'm starting with Word because I think Word is quite used to. So the first concept for us to show is that once you have a connection, we provide technical management support to it, whatever this connection is. So in this case, this is a Microsoft Word. We are doing this Word document as a requirement specification. So once you connect to it, you can see that you have quality, verification, validation, traceability, configuration management, and the rest of the technical management process, including information knowledge management. So if we just jump into the view of quality, what we are going to see and do is now to check, manage, assure, and verify that in this case, requirements, in this case, because we are a requirements connection, they have a particular quality. Okay, so this quality is managed in the way RQA, for those of you who know Reuse Company, is in the market using RQA. So RQA is now offering the possibility to check what the quality of the requirements is using natural language processing tools and all that stuff. For example, in that requirement that you can see here, that's a stupid requirement that has to be filled. So then there's no modal verb, you have ambiguity, and you have a lot of metrics that are not being covered. Of course, there's no time for us to, in 10-15 minutes, to explain you how do we do requirements or models quality. You have to define metrics and you have to define a lot of things. Okay, but at least you can see the concept for us in the Interoperability Hub is that in whatever connection, you have the possibility to digitally manage the evidences of the quality of this particular product. Let's do something different now. So which is what we think that happens in the organizations, we have closed this connection to Word from the SES Engineering Studio, and now we open Microsoft Word by ourselves. So it is here Word, and you can see two things. The first one is that we have the SES Engineering Studio also inside Word. Here it is. But in this case, I don't really think that we are going to use it. We are going to get into a particular requirement and we're going to change it without anybody knowing it. I mean, my people is doing whatever they are doing in their own processes using their tools without needing to be controlled by anything. They just do it. And once they have changed this requirement, we can connect to the SES Word in this case, so that you can now engineerize this Word. You're converting Word into a requirements development to more than management. Okay, so that in that case, now suddenly you have your Word stuff and you have SES in there. What has happened that you have changed something outside SES, and this change has been recorded as change inside SES, and of course you can do quality, traceability, whatever you want, and then you could eventually do some versioning and configurations, check change management and everything that is supported in SES. In this case, I think what this guy is doing is just saving, accepting that this change that was made without any change request and anything. If you want to do it, you can do it. But in this case, okay, we accept it and we put it in the synchronized repository. Okay, so let's close this part and go back to, oh, sorry. Instead of that, what we are going to do is we are going to change again some other requirement. Okay, so what we're going to do is we are going to now disconnecting from SES. We are going to look for change, and we find some changes. Remember that I changed this requirement before. At any time I put it here, so then now I'm going to remove this at any time again without any control of the integration or interoperability hub. So we are working alone in Word. Then at this moment, we are going to go back to our SES, now in this time outside Word, and we are going to connect to Word again. And which is going to happen again is that we are going to see that the differences are there. I'm going to spend some small time showing you what are the differences, and then of course you can see that when you were not connected, someone changed this requirement inside Word, and then you can accept, reject, you can go back to the previous version, you can manage attributes, and you can do all these things. Okay, so the first message in this demo is, for interoperability, you need to provide services to the connections, and we are showing now these services based on change management, configuration management, versioning management, to whatever any single connection. The second thing I've done, I don't know if you have seen it, but the second thing now I've done once I was finishing Word is, I'm going to do it back. Good thing is that I'm going to open another connection. I have a connection to Word. Now I'm going to open a connection to Excel. Don't worry, because we will get back into engineering systems, engineering tools in a second. Just only because we are using, I would say, system requirements in Excel. Okay, so what can I do now with this? What can I do? I can starting to do some small interoperabilities. The first interoperability level for us is to provide universal traceability. So traceability is also a topic in itself within our tools, because through the ontologies we can provide suggestions of traceability automatically, as Craig mentioned, for software and aircraft engines. That is what they are doing. But in this case, we are just simply going to work on the notion of traceability. So, okay, the notion is you need traceability modules between the different connections. So the organization of traceability for making it universal is you have connections, and then you create a traceability module between one connection and the other one. In this case, as you can see here, is a traceability module between, okay, let me see if you see it, between Word and Excel. And you can get some measures on the coverage rate and everything on traceability. And again, what we are going to do now is we are simply going to open the traceability module, select one item in the connection one, which is whatever. select the second item in the connection to, which is whatever, if you're not using the automatic suggestion issues, and just click in the trace and you're doing trace. So this concept of being able to connect to sources outside, not connected by themselves, and selecting different work products and tracing as is universal. If you are opening SolidWorks and you select a part, and then you want to open a requirement or a model in CIMdata, and you want to make this connection of trace between one part and one requirement, that's exactly the same stuff. In order to see how general this quality of BMB or interoperability, traceability issues are, we are now opening quality for another connection. In this case, this Excel. Okay, but the same situation is happening. You're getting measures, and you will get measures for models, physical models, for parts. You could get quality measures. I'm opening also for you to see VMB. In VMB is the digitalization of the verification and validation processes, in this case for verification processes, and you have all the way of managing evidences for you to, in this case, to verify, in this case, requirements. I'm not verifying the system against requirements. I'm verifying the requirements against the measurement of verification that you decide. You can put here the evidences, you can store your videos and your signatures and everything for you to assure that the different work products are correspondingly verified. Okay, so next, let's get a little bit deeper now into other interoperability aspects. Okay, so I'm going to close, or I'm going to close or leave there. I'm not going to close. I'm going to leave this connection to Word, and I'm going to connect to something that for us could or should be the logical modeling. Okay, so we are connecting to Cameo in this case. Okay, so the connection to Cameo includes another connection. We usually offer our customers to work with 3 monitors. This is typical stuff when you're doing this kind of interoperability aspect. You can see that the windows can be moved here and there in the way you would like. So you have their Cameo, and you can have in the left their requirements in whatever tool, Excel, doors, or whatever. In the right side, you have an empty Cameo model. Okay, so we are going to do some a little bit more advanced interoperability. In this case, we are going to generate automatically model parts based on the requirements. So that means that we are going more deep interoperability. In the left, we still have, sorry, down the screen, we still have the traceability model. We can just select one element in the left, one other in the right, and then we can just simply make the traces. But in this case, through interoperability, I think we are going to simply do it automatically. So we are going to say, please do an interoperability between Excel and Cameo so that you can generate what the system understands of model elements inside the requirements, generate them in Cameo, and save them in Cameo, of course, and generate the traces, of course, between the Excel and Cameo. So in order to do that, we have this interoperability platform. You can see it there. Now we have another window. We are going to put it up there. So this interoperability there has the different interoperabilities that you can do. And you can have as many as you want, and you can create your own right away, always depending on the connections that you decide. So if you create a new connection, the only thing you have to do is select the source or sources, select the target, select the operations. You can see there that are append, add, merge, and many others. And then you have some transformations as well. Extract the structure information, or generate models, or generate things, or you can even generate your own, just coding, in this case, C#. Okay, so you can do in principle whatever you would like. So so now that I show you, I'm going to first show you how this interoperability system requirements to CIMdata models in Cameo. So I'm going to show it to you, and this interoperability, sorry, is going to be perhaps a little bit heavy, but what we are doing is we are going to define some requirements patterns, some requirements information structures to be identified in the source, and they would generate models. Okay, These patterns are in the ontology and they are selected there. Sorry for you guys that don't understand. We have 10 minutes and this is a little bit too much. I'm trying to sum up as easy as possible. But the result is that in this interoperability, the system is understanding the requirements, extracting the information out of them properly, generating model elements in Cameo, generating automatically the traces between them, and saving them in the sources. Okay, so now they are asking you which is the traceability model you want to use for generating this, and you will see first that there are some model elements. Well, there's some log information, and then you have some model elements automatically traced, automatically generated here, describing you see the temperature warrior and all this system that we're using together with these traces between the requirements and the model elements that you can see there. They are in the state suggested because they have been made by the traceability, but you can automatically go one by one, accepting or rejecting, or we are going to accept them all just immediately. So now we have generated these traces and these model elements automatically. Of course, you can carry on. Now you have saved this information inside Cameo, so you have it there. And you can carry on doing, as we did in Word. You can carry on in Cameo itself, just synchronizing later on in the same way we did in Cameo. Okay, so I'm going now to do something else, which is I have this model in Cameo. We are going to transfer this model to Capella. Okay, so why? Because we are going to develop in Capella a little bit more deeper physical parts, physical architecture. So I want to start from the logical, and because of whatever reason, I want to synchronize this logical in Cameo with the one in Capella. It can happen to be because the DoD or some Ministry of Defense would like to have this model also in Capella. So we're simply going to run another interoperability, the one that sends the information in Cameo, SysML, transforms it into Arcadia, and just put it in Capella. Okay, so this is the interoperability. Another one, which is selecting a model in Cameo, as you can see there, and it's selecting the output model in Capella, and that's it. We just simply see it and select it and run it. And once we run it, you can just simply get the results. And of course, in this case, these results, as there's a need to do transformations, because SysML is a way of representing models that is different in the meta model and than Arcadia, which is in which way are you going to map elements from elements, and that's it. We just have them there in Capella. It's just a matter of checking this. I'm going to put this in a second in hold. This green is meaning that is coming either new for the repository in Capella and for the source in Capella. So when we save, just simply we will save in both sides, in the repo and in the source. So last interoperability, just to finish with it, is to transform requirements, for example, into issues in Jira. Okay, I'm going to open this Jira stuff, and in this case, it's a connection to Jira. And what we are going to do, well, we have just closed one of these model elements, Cameo and Capella and all these things, and now we are finally done with these other connections, and we have the two connections that we are interested in the screen. The first one in the left is again Excel, and then the second one is Jira. What to do now? The same stuff. Okay, you have another interoperability, and what we are going to do is we are going to run it. I'm going to go a little bit quicker because we are running out of time. So I'm going to go there, and then we just execute this interoperability, and the result is, of course, that you have sent these requirements. You can do some filtering and all that stuff, but I prefer not to spend some time there, so that you can see at the end is that you have all those requirements inside Jira. So from my side, I'm done. Cecilia, thank you very much.
Thank you. Can we go back to the presentation?
Yes, I'm going to quit this thing, and I'm going to open that one, and I'm going to run this one, and there we are.
Okay. So Craig and Juan will answer your questions in a minute. So while you're writing down your questions, I will tell you about our upcoming webinars. The reuse company is probably more known in the market for our requirements tools, and we are preparing a series of short 15-minute webinars to show how SES Engineering Studio can be used as an add-on to Microsoft Word. We call this series Boosting Microsoft Word with Requirements Management Capabilities. The first webinar is called Writing High-Quality Requirements in Microsoft Word, and the dates for this are the 31st of January and the 2nd of February. The following webinars will deal with how to manage requirements in Microsoft Word, how to transform requirements, how to propagate changes from traceability links, and how to report systems engineering artifacts. So let's move on to the questions. I think we already have received some. Let's see. On the slides, there were SES Engineering connectivity with Polarion and Simulink. Does your solution work with all the MathWork projects, particularly System Composer?
This is a question for me, I think. Yes, well, yes and no, depending. Yes, we work with several, at the requirement side, several requirements, ALMs or requirements management systems. DOORS, DNG, RecIF by heart, okay? Teamcenter requirements, PTC requirements, blah, 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 and others perhaps I'm forgetting. And System Composer is not supported yet. We work at the Simulink side. We work with Simulink itself, MATLAB Simulink. We work with OpenModelica, and we are connecting to FMUs and Excel for simulation and function. So for simulations, it's DLLs, so your own simulation produced by yourself, and all these others, and by heart. I'm not extremely sure, but System Composer is not supported yet.
Okay, let's take one more question. Why are monolithic PLM systems not enough for systems engineering? I think this one would be for Craig.
Maybe I can take that, Cecilia. Yeah, in my experience, I tried as the PLM leader to embrace the commercial solutions for systems engineering and even other parts of modeling. And I required teams to use it, to explain to me why it wasn't good enough. And what I learned, most importantly in all that, is the authoring uniqueness of a particular domain, like systems engineering, really drives authors to want to have their, if you will, preferred solution. It's like a tool and die maker who has their favorite tools for making something. So you really can't dictate, use this tool. What you need instead is what we've been talking about today, is interoperability. Now, a lot of the really big PLM vendors have acquired a lot of tools, and they're working to make them more seamless. But it still comes back to this fundamental problem of, do you have a single data repository, or do you have data repositories that are connected to each other? And I'm absolutely convinced it's the latter one. You cannot assume a single repository. Rather, you have to connect them, and to connect them, you need an ontology. I like the way Juan has organized this notion that it's an ontology for a domain. I agree with that. And then you need to be able to enforce it as you do quality checks. So the reason it doesn't work is a lot of PLM vendors grew up in the middle of that chart I showed earlier. They grew up in product development and manufacturing engineering streamlining, which, by the way, is really important and a profit driver for most companies. But the more you move to the left, the more you move to features, the more you've got to embrace other authoring tools. It's just that way.
Okay, so we're running out of time, so let's finish here. So let's go to the closing remarks.
Well, I'd like to thank everybody for the time they spent with us today. And I just want to remind you that interoperability is paramount to your digital transformation. If you haven't been thinking about it, you need to think about it. The most innovative organizations have diverse tool sets, as I've explained, and you need these interoperability techniques that that the reuse company has to be more effective, to allow your innovators tool flexibility. They need that as they embrace new technologies and build new kinds of things. But they also need to trust the source, right? In order to make the source of truth trustworthy, it has to be authoritative. That means that it's useful for the next decision. So I encourage you to take a look at what Juan and his company have come up with, and I appreciate the time you spent today listening to us. Look forward to any other questions you might have. We'll get back to you via email. Thank you, everyone.
Thank you very much, Craig. Thank you, Juan, and thank you
very
everybody
much
for attending.
Have a great day, everybody.
Goodbye.
Thank you. Goodbye.